Section 300 of the National Electrical Code, or NEC, details placement and wiring methods for electrical systems. This section is crucial for ensuring safe and compliant electrical installations in residential, commercial, and industrial settings. The NEC is updated every 3 years, so it's important to refer to the latest edition for the most current requirements. Section 300 addresses various aspects of wiring, including protection, support, and acceptable wiring methods for different environments. Some key areas covered in Section 300 include general requirements for wiring methods and materials. This means that the code dictates what types of wiring are permitted in certain applications and how those wires must be installed to ensure safety and longevity. One important aspect is protection against physical damage. Wiring must be protected from physical damage to prevent insulation breakdown, shorts, and other hazards. This can be achieved through the use of conduit, cable trays, or other protective measures. The specific type of protection required will depend on the environment and the likelihood of damage. Another consideration is the support of wiring. Wiring must be adequately supported to prevent strain on connections and to ensure that it remains securely in place over time. The NEC specifies the maximum spacing between supports for different types of wiring. These support requirements help maintain the integrity of the electrical system and reduce the risk of failures. Section 300 also covers the identification of conductors. Proper identification is essential for safety and troubleshooting. The NEC specifies color coding requirements for different types of conductors, such as grounded conductors, ungrounded conductors, and equipment grounding conductors. These color codes help electricians quickly identify the purpose of each wire and prevent accidental connections. Wiring in damp or wet locations is another critical topic addressed in Section 300. The NEC specifies requirements for wiring methods and materials that are suitable for use in these environments. This includes the use of moisture-resistant cables, waterproof connectors, and other measures to prevent water from entering the electrical system. The presence of water can create a significant shock hazard and can also cause corrosion and other damage. Section 300 also covers wiring in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC specifies special wiring methods and equipment that are required in these locations to prevent ignition. These requirements are designed to minimize the risk of an explosion or fire in these dangerous environments. One specific requirement often found in Section 300 involves the use of approved raceways. A raceway is an enclosed channel designed to hold wires or cables. Conduit is a common type of raceway. The NEC specifies the types of raceways that are permitted in different applications and provides requirements for their installation. Raceways provide physical protection for wiring and can also help to contain a fire in the event of an electrical fault. Another area covered is the proper use of boxes and fittings. Electrical boxes and fittings are used to terminate and connect wires. The NEC specifies the types of boxes and fittings that are permitted in different applications and provides requirements for their installation. These requirements help to ensure that connections are made safely and securely and that the wiring is protected from damage. Furthermore, Section 300 addresses the grounding and bonding of electrical systems. Grounding and bonding are essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and prevent an electrical shock. Bonding connects metal parts of the electrical system together to ensure that they are at the same electrical potential, which also helps to prevent shocks. The NEC specifies detailed requirements for grounding and bonding. Proper conductor sizing is also covered, as conductors must be sized appropriately for the amount of current they will carry. The NEC provides tables and calculations for determining the appropriate conductor size for different applications. Using undersized conductors can lead to overheating and fire. Overcurrent protection is another key aspect, where overcurrent protection devices, such as circuit breakers and fuses, are used to protect wiring from overloads and short circuits. The NEC specifies the types of overcurrent protection devices that are permitted in different applications and provides requirements for their installation. These devices are designed to trip and interrupt the flow of current in the event of an overload or short circuit, preventing damage to the wiring and reducing the risk of fire. Voltage drop is also addressed. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of the wiring. The NEC provides recommendations for minimizing voltage drop. Moreover, the NEC provides requirements for the installation of underground wiring. Underground wiring must be protected from physical damage and moisture. The NEC specifies the types of wiring methods that are permitted for underground installations and provides requirements for burial depth and other factors. Section 300 also covers the installation of wiring in buildings, including requirements for fire stopping and other measures to prevent the spread of fire. Fire stopping involves sealing openings in walls and floors to prevent fire and smoke from spreading through the building. The NEC specifies the types of materials that are permitted for fire stopping and provides requirements for their installation. The NEC also provides specific guidelines for wiring in different types of occupancies, such as residential, commercial, and industrial buildings. These guidelines take into account the unique electrical needs and hazards associated with each type of occupancy. For example, the NEC may have specific requirements for wiring in healthcare facilities to ensure the safety of patients and staff. Wiring in agricultural buildings is also covered, where agricultural buildings may have unique electrical hazards due to the presence of moisture, dust, and corrosive substances. The NEC specifies special wiring methods and equipment that are required in these locations. Section 300 also touches on temporary wiring, where temporary wiring is often used during construction or for other temporary applications. The NEC specifies requirements for temporary wiring to ensure that it is installed safely and does not pose a hazard. These requirements may include the use of ground fault circuit interrupters, or GFCIs, and other safety measures. Section 300 also addresses wiring near swimming pools. Wiring near swimming pools is subject to special requirements due to the risk of electric shock. The NEC specifies the types of wiring methods that are permitted in these locations and provides requirements for bonding and grounding to minimize the risk of shock. The section includes requirements for wiring in manufactured homes, where manufactured homes are subject to specific electrical requirements due to their unique construction. The NEC provides guidelines for wiring in these homes to ensure that they are safe and compliant. Furthermore, the NEC provides requirements for wiring in recreational vehicles, also known as RV. Recreational vehicles are subject to specific electrical requirements due to their mobile nature and the potential for exposure to different environmental conditions. The NEC provides guidelines for wiring in these vehicles to ensure that they are safe and compliant. Section 300 also includes information on wiring in marinas and boatyards. Marinas and boatyards are subject to specific electrical requirements due to the presence of water and the potential for corrosion. The NEC specifies the types of wiring methods that are permitted in these locations and provides requirements for bonding and grounding to minimize the risk of electric shock and corrosion. The NEC covers wiring for solar photovoltaic, or PV, systems. Solar PV systems are becoming increasingly common, and the NEC provides guidelines for wiring these systems to ensure that they are safe and compliant. These guidelines cover topics such as conductor sizing, overcurrent protection, and grounding. Additionally, the NEC includes requirements for wiring of wind turbines. Wind turbines are another source of renewable energy, and the NEC provides guidelines for wiring these systems to ensure that they are safe and compliant. These guidelines cover topics such as conductor sizing, overcurrent protection, and grounding. Section 300 outlines the installation of energy storage systems. Energy storage systems, such as batteries, are becoming increasingly common as a way to store energy from renewable sources. The NEC provides guidelines for wiring these systems to ensure that they are safe and compliant. These guidelines cover topics such as conductor sizing, overcurrent protection, and disconnecting means. The NEC also includes requirements for wiring of electric vehicle charging stations. Electric vehicle charging stations are becoming increasingly common, and the NEC provides guidelines for wiring these stations to ensure that they are safe and compliant. These guidelines cover topics such as conductor sizing, overcurrent protection, and grounding. In summary, NEC Section 300 is a comprehensive guide to placement and wiring methods for electrical systems. It covers a wide range of topics, from general requirements for wiring methods and materials to specific requirements for wiring in different types of occupancies and environments. By following the requirements of Section 300, electricians and other electrical professionals can ensure that electrical installations are safe, compliant, and reliable. It's important to consult the latest edition of the NEC for the most current requirements. The NEC is a complex document, so it's often helpful to consult with a qualified electrical inspector or engineer to ensure that you are meeting all of the applicable requirements. Section 300 also includes tables and examples to help clarify the requirements. These tables and examples can be a valuable resource for electricians and other electrical professionals who are working to comply with the NEC. The NEC is constantly evolving to keep pace with changes in technology and industry practices. The NEC is updated every 3 years to incorporate these changes. It's important to stay up to date on the latest edition of the NEC to ensure that you are using the most current information. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other sources. It is also available online through various subscription services. The NEC is an essential resource for anyone who works with electrical systems. By following the requirements of the NEC, you can help to ensure the safety of yourself and others. Remember to always consult with a qualified electrical inspector or engineer if you have any questions about the NEC. They can help you to understand the requirements and ensure that your electrical installations are safe and compliant. Firstly, ensure that all wiring and placement methods comply with NEC Section 300 to guarantee electrical safety. Secondly, regularly update your knowledge of the NEC to stay informed about the latest requirements and best practices. Thirdly, utilize appropriate safety measures such as personal protective equipment, or PPE, and lockout/tagout procedures when working on electrical systems. Fourthly, always verify that electrical systems are properly grounded and bonded to minimize the risk of electric shock. Fifthly, use appropriately sized conductors and overcurrent protection devices to prevent overheating and fires. Sixthly, protect wiring from physical damage by using conduit, cable trays, or other protective measures. Seventhly, support wiring adequately to prevent strain on connections and ensure long-term reliability. Eighthly, identify conductors properly using color coding and labeling to facilitate safe troubleshooting and maintenance. Ninthly, ensure that wiring in damp or wet locations is protected from moisture using appropriate wiring methods and materials. Tenthly, follow specific guidelines for wiring in hazardous locations to prevent explosions or fires.